Alright, so I made a quick little example where you basically have an assembly of two different parts, where the bottom one is just the regular one, and this one is just uh, a sketch that uses a projected geometry of the outside reference line offset 1 inch. And I just created another one over here in the assembly, so it's referencing that plane of this part. The easiest way is there's a couple of different things. So on this part, um, if we go into it, we'll basically see that this reference right here is of this sketch. So you can right click on it and say adaptive or break the link, whichever one you want to do. So if you turn that off, it's still referencing part 6. So the better way is just break the link and then it goes away entirely. Now this sketch is then unconstrained. Um, so you might have issues with that because basically then it can move all around. There's no dimensions set up because the outside doesn't have that definition. So you'd have to come back in and actually define this. So as you'll see, 6 extensions needed to reference. So it's basically not locked to the origin anymore. So anyway, that's not really what we're talking about. But so then from there, you can then turn off the adaptivity and it'll clear that out. So if you come back up to the top, now you see that that part is still adaptive because it has a work plane off the other face. Turn that off, turn that off. So the easiest way is, so again, if we go up to assembly 4, go down to here, this part's not, this part is. So if we dive into it, so now we're into here, you see as the reference, you can either turn that adaptivity off, and then turn that adaptive off, and turn back to the top, turn that off, and that off. So then you basically have parts that are all now individual, but let's say we open this part up, and it's its individual thing. So this is a locked work plane because I referenced the front of the other part. So instead of actually having it off of an origin plane here, even though it's the same plane, it's referencing there. So you can see that's got that little pin into it because now it's grounded. So if you unground it, now it's saying, oh, I got to go find that part. So if we ground it again, the best way to do it is come back into here, right click and say redefine to the home plane, and then you can come into here and delete that because it's no longer a reference. Problem is, if you come back into here, now it's basically disassociated because it's not adaptive, it's not locked in, it's not constrained. So any reference to anything else. So anytime you do that, you'll basically have unconstrained sketches. It won't be on the origin plane. You'll have more problems. That's personally why I don't use adaptivity very often. Instead, I use a derived part because then it references the shell. So if I basically did a new part, let's say, and then did derive. So if I bring in part 5 here and just make it a surface and hit OK, you can then, start your sketch on that plane, project the geometry of the outside here, then when we offset it 1, now I know that this part is linked forever with this other part. Now you can basically then, let's say, extrude this and go back into our assembly. So let's say delete part 6. So then at that point, if I place part 8, you'll see it has this right here, and you just ground it. It automatically snaps into place. Yeah. So then if we come back into part 5, and we change this to 20, let's say. Now it updates there, we return to the top, and it updates the other part because part 8 is now derived from part 5. So you can do a little bit easier things rather than having stacked layers of adaptivity. This way you actually know which part you're drawing from, and should get you going a little